we have multiplication of algebraic fractions. We know that when we have to multiply fractions, we have to multiply numerator times numerator and denominator times denominator. So we can rewrite that this is equal 9x to power third times, and we have 3xy squared to third power, and in the denominator we have 12x squared y third to second power everything times 6x y squared everything to second power. This is equal. Next, first we have to do the power. So it means whatever we have in parentheses, we have to take to third power. Let me remind you formula. When you have a times b to n power, this is equal a to n power times b to n power. We will just use this property. So this is equal. First expression in parentheses we have to take to third power. So will be 9 to third power times x to third power, and we have times, we don't have to write 3. Now we have to take to third power every expression in the parentheses. This property is only when we have multiplication in parentheses. So we have 3 to third power, x to third power, y, and now when we have power to power, so we have to multiply the powers. Let me copy, maybe we have y to second power and we have to take this to third power. So now same we have to do in denominator. We have 12 to second power x squared. We have to take to second power and y cube to second power. And we have 6 to second power, x to second power, and y squared to second power. So this is equal. Next we have 9 to third power. This is 9 times 9 times 9. So let me maybe rewrite this, because maybe we can reduce something with denominator. So I will put this is 9 times 9 times 9. And next, first I will put variable x. We have x to third power and x to third power. So we copy the base and we have to add exponent. Now exponents. Now I will use property that a to power n, when we have a to power n times a to power m, this is equal a to power n plus m. We copy the base and we have to add exponents. So we have x, and 3 plus 3 is 6. And we have 3 to third power, this is 27. And now we have power to power. When we have power to power, it means that we have to copy the base and we have to multiply exponents. So 2 times 3 is 6. I just use formula. When we have a to power n to power m, this is a to power n times m. So we have numerator and denominator. We have 12 to second power. So I will rewrite that this is 12 times 12, and we have x to second power, so we copy the base and we have to multiply exponents. 2 times 2 is 4. Next we have y, and we have to third power to second, so it will be 3 times 2 is 6. 6 to second power, so this is 36, and we have x squared y to power 2 times 2 is 4. Next, first we check the numbers if we can reduce, because we have only multiplication. So 9 with 36 will be 4, because the greatest common factor for 36 and 9 is 9, so will be 36 divided by 9 is 4, and 9 divided by 9 is 1. Next we have 9 and we have 12, so the greatest common factor for 9 and 12 will be 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. And we can do the same with 9 and 12 next. So this is 3 and 4. What we have else? We have 27. We cannot reduce 27 with 4, so the rest we can copy. So we have now 1 times 3 times 3, so this is 9 times 27. So this is 243. And we have x to 6 power, y to 6 power over, and we have 4 times 4 is 16 times 4 is 64. And now we have x to 4th power, x to 2nd power, so we copy the base and we have to add exponent. 4 plus 2 is 6. The same will be with y. We copy the base and we add exponent. 6 plus 4 is 10. I just use this property. We copy the base and add exponents. So now we see that we have in the numerator x to 6 power and x to 6 power in the numerator and in the denominator. So we can cancel out. So this is 1 and 1. And we have y to 6th power and y to 10th power. So first we will copy the numbers 2, 4, 3, and like before we copy the expression with the smallest power. So y to 6th power is smaller than y to 10th power. And now we will copy 64 and we will rewrite y to 10th power, that this is y to 6th power, because we want to reduce this y with 6th power, and we have times y. 10 minus 6 is 4. Let's check y and y. So the same base, we add exponent. 6 plus 4 is 10. I didn't change anything. We still have in the denominator the same expression. So this is equal to 4, 3, and we will reduce y to 6th power. So we have only in the numerator 243 and in the denominator we have 64 y to 4th power. This is my solution.